Hello and welcome to the Dundas Dashboard Amazon Redshift tutorial. In this video, I'm going to walk you through the process of connecting to an Amazon Redshift cluster from within Dundas Dashboard. Before we get started, you'll need to download and install PostgreSQL. This package contains the ODBC driver required to query our Redshift database. PostgreSQL is an open source database technology and can be downloaded free of charge from www.postgresql.org. Once PostgreSQL is installed on your Dundas Dashboard server, you're now ready to connect to Amazon Redshift. First, I'm going to open up my Amazon Web Services console and click on Redshift to see what clusters I have running. For this demo, I've launched a small cluster with only 2 compute nodes. Redshift allows you to add or remove nodes based on your database size and the complexity of your queries, so you can decide on the appropriate balance between cost and performance. In this case, I don't need a lot of processing power, so I've launched a cluster with only 2 nodes. From the cluster details page, I locate the ODBC connection string. I copy it into memory, and then I switch over to Dundas Dashboard to create the Redshift data connector. Be careful that you copy the ODBC URL and not the JDBC URL. The first step is to create a data connector. Select Amazon Redshift from the provider dropdown and paste the ODBC connection string into the box below, changing the password to match the server settings. Next, I test the connection to make sure it's working. Then I save the data connector, allowing it to detect the tables available from my Redshift instance. At this point, we've taken all of the necessary steps to connect with our Redshift database. As you can see, all of the tables in our Redshift instance are now available to Dundas Dashboard. I can use these to create virtual tables and KPIs, just as I do with any other data source. Now, I've already created a data connector, virtual tables, KPIs, and a sample dashboard to demonstrate the performance of Redshift. 2 of the virtual tables use manual queries to perform a lot of server processing and extract a small result set. When working with massive databases, remember to always perform the bulk of the work on the server and return a small set that you can visualize. This reduces data traffic over the network and improves the performance of our dashboards. Another way to limit the result set is by creating filters on your KPI or virtual table columns. Filters are used to limit the amount of data returned to the client by allowing a user to select a small subset of the data. The third virtual table in our example uses a date filter to limit the amount of data being shown. Let's take a look at the final dashboard to get an idea of what this all means. The top chart uses a date filter to limit the result set. You can see that I've selected data from June 2008 to the end of time. Of course, this data ends in 2008, so that's a small amount of data. The bottom right chart uses the manual query that we saw earlier to limit the result set that's coming back to the dashboard. The bottom left chart uses a manual query to limit the result set, and you can further limit the result set by selecting a value from the dropdown. This dashboard loads in about 2 to 3 seconds, which is an acceptable amount of time. If you were to return millions of rows, of course, the performance would be impacted. For that reason, we always want to either perform a manual query that does most of the processing on the server, or filter the result set using a filter on one of your virtual table or KPI columns. Thanks for watching this video on Dundas Dashboard and Amazon Redshift. If you have any questions or if you want to get started, you can reach us at redshift@dundas.com.